Natural number equation here that's quite similar to a BMO, a British MathS Olympiad question. And we're looking for all natural numbers, that is the positive integer solutions to the equation, ordered pairs. So again, a well-known algebraic identity helps us out here. A minus b quantity squared, a binomial squared. It's well known that that's equal to a squared minus 2ab. This is 2ab right here. And we're doing this because it's going to give us a way to represent m and n, actually. Okay, so that's b squared there. All right. Now, this allows us, again, to formulate some very interesting information that actually leads us to a fairly straightforward solution. Notice that everything in sight here is an integer or a natural number, a positive integer. N's a natural number, 2299 is a natural number. Of course, this coefficient -2 is an integer. So everything's an integer except this radical. And so this radical also has to be an integer. This entire piece has to be an integer in order for the left-hand side to be an integer or a natural number, okay? So that leads to these conclusions right here. In other words, this piece right here says this has to be an integer. The square root of 2299m has to be an integer, and so in a symmetric sort of fashion, so does 2299n, okay? Now that helps us out tremendously because we know that 2299 has a prime factorization of 11 squared times 19. That's a little bit of a computation, but it can be done. But what does this tell us? A and b are both natural numbers, so that forces this entire radicand to be a perfect square. So another way to say that would be it forces m to equal to 19. All right, that would create a 19 squared inside of here, right? Okay, square root of 19 squared is just 19. And then we'll just go ahead, if you want to, we can call it x squared. M has to be 19 times another square. All right, and of course, all the variables here are assumed to be natural numbers or integers. All right, again, if you substitute this back inside here, you see you have 11 squared, 19 squared, and x squared, and that forces a to be an integer like we want. And carrying on in a similar fashion, we can conclude that n is equal to 19 times, we'll call it y, that'll be some different integer perhaps. So we'll call it n is equal to 19y squared, okay? Now, so in a sense, a and b have been kind of dummy variables right here, but we do have this nice representation of m and n. So if we can figure out ways to get bounds on the variables x and y, we'll be towards a solution to this problem. Now let's take a look at the original problem here. Notice what will happen right here. If you substitute m equals 19x squared right here, you actually get root 19 times x right here, and also root 19 times y. Again, remember, x and y are just natural numbers. Okay? But notice that's equal to this. Now, what we can do here, and you guys probably can see the algebra right now, what will happen here, you can factor out the root 19, and I'll just write it down right now because, again, this part right here is equal to 11 root 19. Okay? So the root 19s cancel when you divide, and so what you end up with, this implies that x plus y has to equal to 11. Get a little more space here, folks. So that implies that x plus y equals 11. But y'all, this is really nice. It's one equation and two unknowns, but we know that x and y are positive integers, right? So you see, we can get busy solving that. In other words, it's kind of cool here, even though that's as far as real valued x and y, there would be an infinite number of solutions, but we are constrained by the fact that x and y are positive integers. And so let's just take a look at a few solutions here. Okay, now, and I'll just write it off to the side on this table right here. Let's say that we choose x equals 1. Okay, well, if we choose x equals 1, it's a perfectly valid natural number, that forces y to be 10 right here. And already we know how many solutions there's going to be, right? 1 all the way through 10 solutions. Okay, so again, 1 plus 10 is 11, but what does that lead to right here, folks? That leads to the square root of 19. All right, square root of 19. Now, if you put 10 right here for y, that would give you 100, or that would give you the square root of 1900. And you can just, I mean, you know it works without having to use a calculator, because that does equal to 11 root 19. So let me fit that in there a little bit better. See how that is the square root of 1900, and the square root of 19 is the solution that corresponds to x equals 1, y equals 10. Now let's scroll down just a little bit here and see if we can get another solution. What if we choose x equals 2? If we choose x equals 2, that forces y to be equal to 9, since the equation has to satisfy x plus y equals 11. So that, again, that'll lead to y equals to 9. All right, folks, but watch here. If you put a 2 right here, 2 squared is 4. 4 times 19 is 76. So that's the square root of 76 right here. Okay. Now, right over here, I won't try to do the math. I won't try to do the arithmetic. You guys can do it if you're interested. But this does give you a way to produce solutions here. So this would be 19 times 9 squared. So that would be 19 times 81, whatever that is. And again, not really particularly important what the value of that multiplication is. But again, you can tell almost by inspection here, right? Square root of 81 is 9. You get 9 root 19 right here. Then you get 2 root 19 right here. That adds up to 11 root 19. Now, I got a little more space, so I'll come down here and I'll do x equals 4. Okay. This will be the last one. We'll call it a day. So if yeah, x equals 4. I skip just because I'm running out of space here. So I'll do x equals 4 just because we have more room. So if x is equal to 4, that implies that y must be 7. Okay, so we'll do y equals 7 right here. Now, by the way, y'all, if the question had been how many solutions are there, you could say 10 automatically by looking at this, right? 1 through 10, right? 1 through 10 are the only integers that's going to satisfy this. So there's going to be 10 solutions. So that would have been a quicker process just to say, okay, there's 10 solutions done, next question, right? But we're actually producing the solutions right here. Now, so what happens right here? 4 squared is equal to 16, right? So you would actually have the square root of 19 times 16 here. And y'all, I'll just use the dot to connote multiplication here. Juxtapose the two things, place them next to each other. So again, 4 squared is, you got 19, and 4 squared is 16, so you have 19 times 16 here. Okay. Now, right here in a similar fashion, you would get 19 times whatever 7 squared is. What is that, 49? 7 squared is 49, so you can write down 19 times 7 squared. I'll just go ahead. I'm pretty single-digit multiplications are not taught in elementary schools in the United States like they should be. Okay, so you got 19 times 16 right here is the radicand, and then 19 times 7 squared right there, okay? So folks, again, that's just, you see the idea, and I'll go down. We would terminate this condition at x equals 10, okay? You see these, you would get the symmetry happening. You would x equals 10, y equals 1 would be the terminate condition, and it would produce just the opposite symmetric solution that we did on step 1. So you'd end up with a root 1900 here. All right. And then, what was it, root 19? Here. So kind of at the halfway point, they switch the roles again, and it's not unexpected. And let's see if we can keep this on the same screen. You see how we can't. But right here, notice that we had root 19 and 1900 in the roles of m and n right here. And then when you just work your way down, the variables reverse, and you get root 1900 times 19. Root 1900 and root 19. And notice that, again, the counting aspect of this, you have x equals 1, 2, I left out 3 and all the rest of these, but just by construction here that you're going to have 10 solutions. But anyway, this was similar to a BMO problem, and hope you enjoyed that one. I liked it. It's a little like integer programming in some regards.